Hello.
So we are back.
And this time we are moving forward with the learning process. Now, I see a lot of confusion on the chat. And like how I told you from the beginning, I try to prepare you. Learning electronic for repairs is a little bit different compared with regular electronics. And last video was like probably nearly 2 hours video just speaking about resistors. Everything on when you're doing repairs, what you see actually is a resistance. A transistor, a resistance. Capacitor, resistance. Diode, resistance. Everything is a resistance, And you won't understand that, but that's how someone who's fixing things is seeing the things, the components. Transistor has an internal resistance, right? Capacitor has an internal resistance. Actually, capacitor is a way how you can short the AC or RF, That's what is happening, has an internal resistance. Diode, same thing. Apart from what the diode is doing, has an internal resistance where we are losing current. So everything is down to a resistor, Now, you remember what we learned?
Maybe.
So, it goes on a ear and goes out from the other ear, and it's...
No? It goes on the ear, it goes out from both.
You know what?
No. Actually, I think I got it. I think.
No, look.
Yeah.
Maybe you will think, and maybe the people that are watching, they will think, okay, maybe she will learn, maybe she will not, right?
Yes.
Not me. So I know 100% you will learn electronics in 5 months,
Okay.
And I'm trying to do it less than 5 months, to be like an advance in electronics. You understand? So I'm trying to push the things.
Yeah, but there will be too much information on short time.
Yeah, I know. But I know you can. That's why I'm getting pissed off when I know you can, but you don't. You understand?
Yeah. Control your anger.
Yeah.
That's how your viewer said.
Yeah, but I know you can. That's the thing. I'm not pushing things if, okay, you don't have. What?
It's actually, he's not angry. Trust me.
No, I'm the victim here.
Of course.
You know what? One day I will film Diana, how Diana is doing when I ask her to buy a packet of cigarettes.
Oh my God.
It's like possessed, like I'm the victim. Right?
Right.
Wow. Okay, so what we are learning today? First, let's remember what we learned last time,
Yes, we learned about
resistors, right?
Resistors, yes.
So what we learned about resistors?
We learned about resistors in serial mode and resistor in parallel mode. Yes.
So one more time, just to remember, you know what I mean? Just to remember, because we are moving exactly with the same thing.
Okay.
Yeah? You're not ready to move from the resistors. Okay, so we have two resistors.
Yes.
Right? Mm-hmm. Good. And they are connected together. Okay?
Yeah.
So, usually you'll not see resistors which are not equal. Like the example I gave you, like you have a 10 ohms and you have 1,000 ohms, which is 1 kilo ohm, and okay, I said, what will be the total resistance? Mm-hmm. Right?
Mm-hmm. Yes.
But in the repair, you'll see this. On a working device, you won't see it.
All right.
You understand?
Yeah.
Okay. So pay attention here. Yeah? I will ask you something simple. Something simple, yeah?
Simple for you or simple for me?
Should be simple for you. So we have one resistor here.
All right.
We have one resistor here.
Yeah.
Yeah?
Mm-hmm.
Good. And we have one resistor here. Yeah?
Yeah.
That's very simple?
Till now, yeah.
It is. We have dots here.
Mm-hmm.
and they are all connected together.
All right, that means they are connected in parallel.
Yeah. Okay?
Yes.
So if here we have 10 ohms, here we have 1 kilo, here we have 1 kilo.
Right.
What is the total resistance of this circuit? Estimate.
Estimate.
Yeah.
It's around 8 ohms.
Great. I can't believe.
But
No.
You said, right, the lowest one, right, you cannot go up.
Yeah.
So you always go down.
But
in parallel.
I want to give you an example. This is
Okay.
fantastic, actually, you remember. You know why this is important?
Why?
Why? I will show you why. On like any device, let's say laptops, yeah?
Yes.
Let's say laptops, yeah? So on the laptops, you have like the main power rail, okay, which is 19 volts, right?
Mm-hmm.
Okay. Then you have power supplies. You understand? You have power supply, which usually they have 2 MOSFETs, 1 coil, 1 capacitor, things like that. But let's just say you have power supplies, okay?
Yeah.
Those power supply, usually the resistance is high, especially when they are not working, when they are off, okay?
Okay.
Good. Now, those are failing. Like, okay, you have a shorted capacitor, the capacitor are going to ground, but we haven't learned yet about the capacitors, yeah?
Okay.
So either you have a shorted capacitor, either you have a shorted MOSFET, but that's not important, okay?
Mm-hmm.
You have a shorted capacitor, you can have around few ohms down to 0. You have a shorted MOSFET, you can have a dozen ohms, yeah? So if usually you cannot disconnect those power supply to test them individually to see, okay, let's see what resistance have every power supply. You understand? You can't, because they are part of the circuit.
Okay.
You know what I mean? You cannot disconnect them.
Mm-hmm.
But when something goes wrong, yeah, so instead here of very high resistance on the, yeah, you will have low resistance. So tested from here to ground, you'll find like few ohms. Yeah? So you see the main power rail is shorted.
Okay.
Now if this is shorted, let's say this capacitor has 5 ohms, okay?
Yeah.
The idea is what other capacitor value or what other power supply value it will have on the circuit.
It will have more than 5 ohms.
More than 5. More than 5 means what? Like high resistance?
Yeah.
Why?
I don't know.
But why say higher resistance?
Because that one has 5 ohms.
Yeah. Okay. Let's say here you don't have power supply, you have resistors. Yeah, down to ground.
Okay.
We just spoke like a few minutes ago about this, yeah? The resistor. And this resistor has 5 ohms. What does resistor it will have?
Well, you have to measure them.
If this resistor have 5 ohms, yeah? What other resistor it will be? What is the value? If I check the resistor, what is the value of the resistor? Yeah, they are connected here in parallel. You can see?
Yes.
They are in parallel. We just have a picture with resistors 2 minutes ago.
So if the... Wait a minute. Now I'm confused. So wait.
Yeah.
If I said the other ones have like 4?
How can I have 4 if they are connected together? You see?
Yes.
They are connected exactly together.
Yeah.
You know what? Let's go back because of course here is confusing, yeah?
Yeah.
I can understand that. Let's go back. We are not ready for something like that. So one more time, we have 3 resistors, yeah?
Yeah.
These resistors have 5 ohms,
Okay.
yeah? What will be the total value of this circuit? What will be the total resistance?
But you don't know. the other two resistors, how much they are? How you can say how much will be the total if you don't know the other two?
Okay, you look me here.
Because you gave me the example, right? So if those two, the other two, has like 1 kilo ohms each,
Yeah.
right? The total resistor will be like 3 ohms.
Yeah.
Yeah, but you don't know the other two.
I don't care about the other two. Yeah, just let's forget that resistor has 5 ohms.
Okay.
This circuit resistance has 5 ohms. Yeah.
Okay.
What is the resistance of the resistors? Like any of this one, any of this resistor. If I check with the multimeter, like on any resistor, what it will be the resistance? You can see I can check here, I can check here, I can check here, I can check here.
All right, that's different thing.
Okay.
Should be around
Okay. Okay, 5 ohms, you were checking how you check a circuit. You check here, and you check on the other side, here.
yeah.
Okay. So what is the resistance? If from here to here you have 5 ohms, what is the resistance of each resistor?
It will be 10.
So look here, if you check here and you have 5 ohms, you see those tracks? Those they have 0 ohms. You understand? So if from here to here, I have 0 ohms. You understand? Okay. From here, yeah, or from here to each resistor, I have 0 ohms. Those are tracks. You understand?
Okay.
So if here, from here to here, I have 5 ohms, yeah? And this track is 0 ohms and is going to the resistors. What the resistor value it will be?
5 ohms.
What the resistor value of this one it will be?
5 ohms.
And this one?
5 ohms.
You understand? It's not important what is the value of the resistors. What I know, the circuit has 5 ohms. Okay. And what I know, even if I will check each resistor on one side, it will be 5 ohms. You understand?
Okay.
Maybe one has 6 ohms, the other one has 500 ohms, and this one has 500 ohms.
But the total
the
is
total
5.
resistance.
It's 5.
Exactly.
So it doesn't matter. Okay.
It is matter. You have an issue. You don't know what value has each resistor. I understand that. You have a problem.
Yeah.
Yeah? But it's about what data you get from this circuit. The circuit has 5 ohms.
All right.
Yeah? You don't know which one, the value of each one. You don't know it.
Yes.
Yeah? And going back to, let's say, lepto repairs, they will not tell you on the schematic, okay, what resistance has this power supply. They won't tell you.
They will tell you only the total?
No. They won't tell you even the total. The schematic is about how a thing is working, not how a thing is getting faulty.
Okay.
You understand?
Yeah.
Repairing, it's a detective work. So we are getting data, like this data, what we have. We have 5 ohms. Yeah, that's what I know. And I'm working with what I know.
All right.
You understand?
Yeah.
Okay, let's go back to laptops. Okay, on schematics, to avoid using like a big, long track, yeah, the ground track, they are using this, okay? So that means they are connected to ground. You understand?
Okay.
Ground meaning minus.
Yes.
Okay? So all this, I can draw a line and it will be ground. Okay?
Okay.
Good. So now we have 19 volts. So this is our main power rail, and this capacitor is getting faulty and has 10 ohms. Yeah? What this capacitor value it will be?
10.
10. Because you see it's connected.
Yeah.
What the value of this capacitor it will be?
10 as well.
Okay. What about if I check the power supply here with the multimeter?
It should be 10.
What about if I check here?
10. No?
Yeah. And here?
10.
Okay. 10 ohms meaning what?
The resistance.
The resistance. Okay. So what we know, because the thing is what we know. We know that the current, it always choose the shortest path to ground, right? Yes?
Yeah.
We spoke about that. So the highest current, yeah, on this circuit, because you don't know which one has 10 ohms, where it will be the highest current? The highest current, it will be on this circuit, or this, or this. That's the thing, that's the question. If your circuit has 10 ohms, yeah?
Yeah.
So checking from here to ground, I have 10 ohms. But it will be the current path.
Yeah.
What it will be the current path? I said the current, it will choose the shortest way. Yeah?
Yeah.
Shortest way, what means? The lowest possible resistance.
Yeah.
Yeah?
Yeah, but it will be 10 ohms.
I know it will be 10 ohms.
Yeah.
I know that. But from where the current it will go? Because, you know what I mean? He will choose the shortest path. Your circuit tested has 10 ohms.
Yeah.
But actually, your circuit doesn't have 10 ohms. But just because it's on a parallel mode with this faulty capacitor here, just because it's on a parallel, so testing with the multimeter, everything, it will show you 10 ohms.
Okay.
You understand?
Yeah.
But the current, it will not goes like here. What's the point? Or like here, you know? Here is nothing, the resistance here is very high. But just because it's connected on a parallel mode with this thingy, everything, it will show low resistance. You understand?
Yeah.
But the circuit doesn't have low resistance. So the current, it will choose the shortest path. The multimeter can't do that. That's why checking with the multimeter, it will give you 10 ohms. But the current, it will goes only on one single direction. Yeah? So this, it will be the current path. Because it's looking to go to ground. Yeah? It will choose the shortest way, which is 10 ohms.
Yeah.
You understand?
Mm-hmm.
Yeah?
Yeah.
You sure? Just tell me what you don't understand. That's the thing. You have to tell me. Because that's the reason why I'm using the power supply to find a short. That's the reason why I'm not using the multimeter to find a short. I'm using the multimeter just to see if there is a short or not. But I'm not using the multimeter to find a short.
Okay.
It is a way to find this problem, to find this faulty capacitor with a multimeter?
No, because you don't have.
Yes,
current.
it is.
It is?
Yes. You check with the multimeter and it's 10 ohms, right?
Yes.
You can start removing, so this is complicated. You can start removing the capacitors.
And
Okay.
check again, right?
Huh?
And check again to see
Yeah,
if
check if
there's-
it's short.
if-
So of course, if I remove this 10 ohms capacitor, it will not be short.
yeah.
Yeah, right?
Yes.
So either you remove the capacitors manually, you have to remove them, or I separate the power supply, which again is nearly impossible.
Okay.
You understand?
Yeah.
So this is long. You don't have this time when you are doing repairs. That's the best way is with current, because the current is not like multimeter. Yeah, I will have 10 ohms everywhere. No, the current will goes on a single direction. It will choose the shortest path to ground. And that's how I will have a circuit. You understand?
Yeah.
You're not very convinced. Okay, let's do it a different way,
No,
yeah?
no. Wait
no.
a second. But what about move? What about this one? It's faulty. right?
Yeah.
This one.
Yeah.
This one is 40.
Yes, yeah.
The current will go like this.
No, why? That's the shortest path?
Yeah.
Your power supply is not faulty. This has very high resistance. It will choose a shortest path, I just said. It will go like that, I just said.
Oh, anyway, yeah, like that. No,
Yeah, obviously. It will choose the shortest path.
Okay.
But let's prove this, yeah? Let's prove. So find the 10 ohms resistor and 1 kilo ohm one.
10 ohm resistance.
Yeah. You can use the power supply. You can use the multimeter to check. Let me grab the thermal camera.
And this is 1,000.
Okay, connect them on a parallel.
Like this.
And this one, connect even this one. This one is 20 kilo ohms, yeah? No, not like that. No. No, because we can't see. So let's connect all three. Yeah? Okay?
Yeah.
Like that. So now we have some space, right?
Mm-hmm.
Good?
Yeah.
Now let's come with the power supply. We don't know the value, you understand? Actually, I don't really care about the value. I want to see where my current is going, you understand?
Yeah.
Okay. Now, let's use the power supply. I'll lower the voltage, I'll lower the current. And the voltage is not very important, the current is important.
All right. So,
Just touch on the ends, yeah? What is the current? 0.03 is,
0.03 amps.
yeah, which is?
3 milliamps.
No, it's 30.
Oh, 30.
Yeah.
Okay.
So the other zero is hundreds, yeah?
Yeah.
So this one, yeah. Okay?
All right.
So it's 30 milliamps, yeah?
Mm-hmm.
Let's see our resistor. Yeah, just connect. We can see on the thermal camera. So check there. Let me do it like that.
All right. So the bottom one is go higher.
1 second.
Oh, okay.
What do you know? What do you know about that circuit? Has 10 ohms, right?
Has 10 ohms?
Yeah?
Yes.
But you don't know which resistor has 10 ohms.
Yes.
Okay. What about now? Now you can see which one has 10 ohms.
The bottom one, yes.
You see? Why?
Because it's getting hot.
It's getting hot because of what?
Because of the current.
Exactly. Like how I said, the current will choose the shortest path to ground. You understand?
Yeah.
That's the reason why the resistor is getting hot. Yeah, hold more. I raised the current a little bit. What's the current now?
It's 120 milliamps.
So check there. Check there.
Yeah.
Yeah? So the first one is very hot, yeah?
Yeah.
The second one is less hot.
Yeah.
So the second one must be the 1 kilo ohm one, right?
Yeah.
It's still some power is still going on that resistor. You remember we spoke current, I1, I2, I3 from each resistor.
Yeah.
They are coming like you add them. I total it's I1 plus I2 plus I3, you remember?
Yeah.
Okay. So you can spot the first one has probably 10 ohms. The next one probably has 1 kilo ohm because it's getting just a little bit warmer.
Warmer.
And the last one, which is not getting warm at all, probably is the 20 kilo ohms one.
Yeah.
So now you understand?
Yes.
In the same way we are fixing stuff. We are coming with current and we are paying attention.
What is getting hot?
Yeah, basically, yeah. Yeah.
Okay.
Yeah?
Yeah.
It's not hard,
It's not.
right?
Yeah.
So that's how you find. So you see, we just found out from 3 resistors, yeah, which one is the lowest one?
Yeah.
Yeah, now we have 10 ohms resistor, but maybe it's not a resistor, maybe it's a short, it's something shorted there. And that's how you find out when you have a circuit with multiple things, connect them on the parallel mode.
Okay.
You understand? That's the reason why I'm using so much the power supply when I'm fixing laptops. Not only laptops, whatever I'm fixing, whatever power rails I'm checking.
Right. Look,
Okay?
easy till now.
It's easy till now, right?
Easy. Yeah.
Okay. Now I will play a game with you. The game is called the hidden component. Yeah?
Like hide and seek?
Yeah.
Okay.
Yeah, just give me 1 second. Okay. So the component is hidden. Yeah?
Okay.
We're gonna do the same thing. First, you're gonna check the total resistance. So check with the multimeter. With the multimeter.
Oh, with the multimeter. Okay.
So that's your circuit.
All right.
So what is the total resistance?
Can I do like this?
Yeah, you can. It's infinite resistance.
It's 0.
Yeah.
Okay.
Let's go. Yeah. So check now. So what is the resistance?
It's 3.5 kilo ohms.
Good, good. If we know the resistance, we can calculate the current which is going through your circuit, right?
Maybe.
Huh?
I don't know formula.
Okay. You don't know the Ohm law? We just spoke on the first
Yes,
video.
but
No, don't worry, don't worry. I will write it. Okay.
okay.
Okay, so the resistance is 3.5 kilo ohm. Let's find the current which is flowing through the circuit. Yeah?
Yeah.
So the current, applying the Ohm law.
It's volts divided by resistance.
Okay, which is, so we have 2 volts on the power supply, yeah?
All
So
right.
2 volts divided by
3,500.
3,500, 0.005. So the current,
It's 30.
yeah,
0005.
yeah.
Okay.
So 0.0005, right?
Yeah.
Okay. So that it will be the current it will flow on this circuit.
Yes.
Yeah?
Yeah.
Good. Now let's check together.
Okay.
With the power supply, not with that one, with the power supply, the current which is flowing on the circuit. Let's see. What is the current?
It's 0.16.
Which is?
160 milliamps.
How? You calculate. You told me 0.000.
Yes, according to the Ohm law.
Okay. Okay, let's go back. You see, this is a common mistake on when you're doing repairs, yeah? So you check with the multimeter and you have one resistance and you say, oh, okay, it's fine. Here is no short. And then we are coming with some current. You see, wait, this is a lot of current is going into this circuit.
Yes.
You understand?
Yeah.
So what is the current? What is the resistance based on the current? So what you check? What current it was?
It was 160 or 140?
160.
160. 160
milliamps.
milliamps. Yes.
Now let's check actually the resistance of this circuit, because this resistance, 3.5 kilo ohm, it's a lie.
Okay.
You understand?
Yes.
So this one doesn't apply, it's a lie. Okay?
Okay.
So how we are finding the resistance?
Resistance is
Yeah,
voltage
yeah,
divided by current.
by current.
Yes.
And which is,
Voltage is 2 amps, right?
yeah,
Divided by 160 milliamps, which is the 0.16 amps. That means
1 second. So we have 2 volts.
2 volts divided by 0.16.
Okay. 2 volts divided by 0.
0.16. It will be 12.5.
12.5 ohms. So the resistance is 12.5 ohms. So what was wrong here? Because even now, if you check with the multimeter, it's 3.5 kilo.
Yes.
But actually, the resistance is 12.5 ohms. This is, it's a big error. You know what I mean?
Yeah.
Why? You don't know why?
No.
Because we have this secret component here.
Okay.
Okay? Which is separating the circuit. Okay?
Mm-hmm.
And usually, that will happen when you have semiconductors.
Okay.
What we have here, but you haven't learned yet, but that's not the point what I'm trying to make.
Yeah.
Yeah. So what we have here is a diode.
Okay.
You understand?
Yeah.
It's a diode, but it can be a transistor. You understand?
Has only 2 legs. Transistor has 3 legs.
Yeah, I know, but that's not important.
Okay.
It's about the separation of the circuit.
Okay.
You understand?
Yes.
So you see, if you check with the multimeter here, yeah, it will give you like 3.5 kilo. If you check with the multimeter here, it will give you like 10 ohms or how much it was, yeah? Okay. But many times you don't have access to this circuit and all you have access is here. You understand?
Okay.
But anyway, you are not sure what is here. You are sure about this. And usually that's how the charging port on the laptops are connected before the semiconductors. Like on the laptop, you have 2 MOSFETs, yeah?
Okay.
So you cannot check actually your main power relay shorted because of the semiconductor. You understand? Yeah, you can go and check exactly here, okay?
Yeah.
But you can get it wrong if you check here
Obviously.
with the multimeter. I can't get it wrong with the power supply. You understand?
Okay.
Because if I send the current, it will give me actually the real current flow.
Oh.
That's why using the power supply in repairs, it's a lot better compared with the multimeter.
With the multimeter.
With the multimeter, you can check like passive components, yeah?
Yeah.
But the power supply can tell you more about a fault.
Yeah, that's true. Because we checked with the multimeter and it was like 3,500.
Yeah, exactly. So now everything is clear. Can we move from the resistors? Can we move forward?
Yeah.
Yes.
Yeah.
One more thing which I didn't tell you is adding more resistor on the parallel mode, you increase the power. And someone correct me on the video. He said, no, sorry, these are 0.25 watts resistors. And that's right. So in this case, we have 3 resistors. What will be the power of the resistors?
What will be the power?
Yeah. The power have nothing to do with the resistance of the resistors.
Okay.
You understand?
Yes.
It's all about how much power they can take. And power, we know, is the relationship from the
voltage and
current.
Current.
Yeah. So if one resistor has 0.25 watts, 3 resistor, what is the power?
It will be higher.
Yeah, wait, how much?
It will be 0.25 times 3.
Yeah, and how much it is?
It will be 0.775.
Exactly. If you have 4 resistors, it will be 1 watt.
What? Yes.
Yeah?
Yeah.
It's that simple.
Simple.
I'll give you a practical example why they are using resistor on the parallel mode. You see, this is the TV board. Let me see if I can zoom it more. Yeah, I can. Check here. If you can't see here, you can see on the screen. You see the resistors are in the parallel mode? You can see them?
Yes.
Yeah?
Yeah.
So they are using resistor in parallel mode there where it has to be achieved or of higher power. You understand?
Yes.
So that's why they are using, because what is the point to use two resistors of 20 ohms to obtain 10 ohms, right?
Mm-hmm.
I can put like straight away a 10 ohms resistor. It's no point putting resistor on a parallel mode on the real life.
Yeah.
Okay? The only thing why you are putting resistor on parallel mode is to increase the power. These are SMD resistors, yeah? That's how they look.
Okay.
Yeah? And you see here you have 3 resistors on a parallel mode.
Yeah.
Okay?
Yes.
Clear?
Clear.
Why the resistors are connected on a serial mode? Not sure if I can show you here on this board. Yeah, I can. I can show you here. Yeah, I can show you here on this board.
Wait, if those are connected in parallel mode to give you more power,
Yes.
if you put them in serial,
Yeah.
you reduce the power.
No, the power rate will be the same. You are not reducing the power. If I put those 3 resistors on serial mode, I will still have 0.25 watts.
And then
Just understand the watts has nothing to do with the resistors, with the ohms or kiloohms. Yeah?
Okay. Yeah. Then you put them in
Serial mode.
serial
Yeah? Why?
to decrease the current. No, to increase the voltage. To not to increase, to decrease. Wait, to decrease.
Yeah. But the voltage, yeah, that's not important. Trust me, this is not important.
Okay.
Yeah? The resistor actually is decreasing the current, and you're right.
The
yeah?
current, yes.
The voltage is because you don't have current, the voltage it will drop. Okay?
Yes.
So that's what the resistor on the serial mode are doing.
Yeah.
So what is the point of using 3 resistors on a serial mode when can I use 1? It doesn't make sense. So instead of using 3 resistors of 10 ohms, why not I'm using only 130 ohms? You don't know why, right?
No.
Look, here is a practical example. So check here on this board. You see those resistors are in serial mode. Are in serial mode or not?
Yes.
You have 2 in serial mode, and then you have 1 more. You have 3 on the serial mode. You can see?
Yes.
It's 1, 2, 3. You can see them?
Mm-hmm.
Huh?
Yes.
So they are in the serial mode. And they are used on the power supplies and TV boards.
Yeah, but why?
Why? I will tell you why. Because of the potential difference from the ends of the resistors.
Potential difference?
Yeah, let me show you on the schematic. Okay, so on the real life, yeah, what is the point using 3 resistors on the serial mode when you can actually use 1?
Yeah.
What is the point? You know, it doesn't make sense. Why you use 3 resistors? When you have a very high potential between the ends. Let's say, like on this TV board, yeah, here I have, and yeah, so here I have around 300 volts. That's on a TV board. And the purpose of this resistor, and these are like probably like 100 kilo ohms resistors, yeah?
Okay.
And the purpose is on the other end to get probably like, let's say 6 volts. Yeah?
Yes.
Now think you have only 1 resistor. Okay, so here you have 300 volts. So instead of having 3 resistors of 100 kilo ohms, I use 1 resistor of 300 kilo ohms. Right?
Yeah.
And here I have 6 volts. Now you see the potential difference between the resistors pins. Yeah?
Yeah.
It's about 294 volts.
Yes.
Now, this is a very high difference, potential difference on this resistor. And it's very easy to have like a spark jumping inside of the resistor or outside of the resistor.
Okay.
Because the potential difference,
Yeah.
the voltage is very high on one end and very low on the other end.
Okay.
So that's why they are using more resistors. So if I have 300 volts and I have 100 kilo ohms resistor, what I will have here? Here I will have 300 volts on this point. On this point, I will have 200 volts, right?
Yeah.
On this point, I will have 100 volts.
100, yeah.
On this point, I will have 6 volts. So the potential difference from here to here, it's about 100 volts. From here to here, it's 100 volts. And from here to here, it's 100 volts. Which is lower compared with having 300 volts on one side and 6 volts on the other side.
All right.
That's the only reason why they will use resistor on a serial mode.
Okay.
Yeah?
Yeah.
It's clear?
Clear.
Okay, I'm happy we saw this. I believe it's time, we should take a break. What do you think?
Break. We just started.
What do you mean we just started?
Oh, to take a break and see you in the next lesson.
Yeah.
I thought we take a break from all this. Like we just started. We did not learn that much.
You know what's the point? We have to let that sink in. All this information, you have to let it sink in. Yeah?
Okay.
You have, just to get printed on your brain so we can use it on the next lesson. Yeah?
Yeah.
Which is a little bit more important. Yeah?
More and more.
Yeah, more and more. Yeah, the fix goes harder and harder.
It does.
But you did understand today, yeah?
Yes.
Okay. That's fantastic. So I'm going to stop now. I will say thank you for watching.
Like and subscribe if you like the video.
And see you on the next one.
Bye.
Bye.